Good question.
Features.
I've already bought it, so.
Too late for you, right? All right. Well, good evening. Thanks for coming out, everybody. I know you probably all just got off work. I know I did. This is a talk I'm going to give on sustainable test-driven development, and I really want to point out that that's going to be the focus, is the elements of sustainability. So this is not a comprehensive talk on TDD. Try to do that in an hour. But I do think this is kind of a critical thing, and I'll explain why I think it is, especially at this point in the history of this thing we call TDD. But first I'll just kind of introduce who I am. My name is Scott Bain. I do actually recognize some faces, so I think a few people here know who I am. But I work for this company called Net Objectives. We're based over on the east side in Bellevue. We're basically a training and consulting and development firm. Those of you who may know Al Shalloway, who wrote Design Pattern Explained, he's our fearless leader. So I spend a lot of my time traveling and teaching and speaking and doing some writing. I just recently finished this book that I've been working on for seemingly forever. So a few of you probably have been those who have been egging me on to get it done. I just wanted to let you know I finally did it. I brought a copy too if you want to look at it. But part of this thing about test-driven development and the way that I want to talk about it relates very much to the notion of emergence in design. Because I think testing is a big part of that. I think patterns are also a big part of that. And I also think there's an awful lot of confluence between the two things. And I want to take a moment to point that out as well. By that I mean, there are a lot of people who would say that patterns are kind of an old thing, and their day has passed, and that TDD is really the new thing that has replaced them. And I don't think that's true. I think that they're actually very synergistic, and used together are actually greater than the sum of their parts, as they always say. So anyway, that's really what my book is about. It's about that synergy. And so we'll be talking about some aspects of it in this talk. A little bit about my background. I've been in development this is my 35th year, which is 10 years longer than I've been married. The primary bulk of that time was spent working in broadcasting. I worked for CBS television and radio, automating their business. And was there for well over 20 years. And because I was there when they started from basically not being automated, literally manual typewriters and things like that, to what they are now, which is completely digital in every respect. And I happen to have been there during that time. I've had a fairly broad background in business automation and stuff everywhere from like accounting kind of things, because broadcasting has that, up through stuff like music automation for radio and things like that, to really weird stuff like controlling robotic studio cameras and things like that. So it's kind of industrial stuff. So I've had experience with a little bit of all of that. And so that's kind of who you're dealing with when you're going to be here. Also, had a lot of interest in a lot of ancillary things, and I find actually that they do really sort of inform the way I think about software. One of those things is the space program. So you talk about engineering and the things that they did to be able to get us to the moon. And yes, we did go to the moon. There's a lot of lessons in that, and I always look for opportunities when I can learn from what they did, because that's a pretty amazing thing. So occasionally stuff like that will crop up. That's why. It's just my personal passion. Okay. All right, so in talking about what we want to talk about tonight, the first thing I want to do, just to kind of set the stage before we even really start talking about it, is really talk about this notion of test-driven development with the test in quotes. Part of the challenge of TDD is getting it adopted in an organization. How many people here would say that they're doing it now? Oh, not too bad a number. How many people here are writing unit tests now for your company? A much bigger number, okay. So, there are some challenges in getting people to understand when you suggest maybe to your team or your boss that you might want to try this, why that would be and what it is you're talking about, right? Because most people have this definition in their mind when they think about a test. They think about it as, well, I've kind of bolded the things, a way of evaluating something, of determining the correctness of something, or it's in fact that it's even there, or the truth of it, or determining whether the behavior of it is correct, or whether it contains the right domain knowledge, things like that. In other words, taking something and holding it up to a bright light and saying, here it is, and it's right or it's wrong. And of course, when we talk about that, we think about what you do after development. We think about how you assure the quality of something. So when we talk about the idea that testing is a part of development, it seems a little strange. And one of the things I want to do is change the way we talk about TDD. Not just to sell it, but because actually in changing the way we think about it, it changes the way that we do it. So I'll get into the details of what I mean by that. But I just wanted to kind of put this up here as kind of the intro to that. Okay? Oh, one more thing I forgot to say. This is a brand new presentation. I've never done this before. I do a lot of presenting around, but this one is new. I made it just for this purpose tonight, and then I hope that if it's a good presentation, I'll be able to use it in places where I get paid to do it. So you're the road test, basically, and I will give you a couple of warnings about this. The first thing is, when it comes to estimating how long a presentation will be, I'm absolutely atrocious. It doesn't matter if I get up and do it in front of my wife or whatever and time myself, I'm always completely wrong. So I tried to make sure that it wasn't too long, because I know you guys all work today and you don't want to stay here all night, which means it's probably too short. So I'll just say that. I did bring some ancillary materials to kind of fill the gap at the end if there is one, so hopefully that'll do that. But I just tell you, I cannot estimate the time of a presentation. I'm just really awful at it. So probably won't have enough material. I don't know. We'll see. Okay, so here's our agenda. The first is this idea of kind of redefining what TDD is in the first place. And part of that is talking about which tests we write, how to select the things that we choose to test, and maybe sometimes even more importantly, which ones we don't write. A lot of people think that you're doing TDD if you're testing everything. And I'm going to suggest that you might be doing TDD, but it's not going to be very sustainable. Okay? Also, we want to define the good. What's a good unit test? And I'm going to suggest that a good unit test from the quality assurance perspective and a good unit test from the test-driven development perspective are rather different things. And how many people here are testers? Okay, we want you to keep your job. QA is very important. It's just different from TDD. And what we really want to do is cooperate with you and support you in your job and provide you with code that's in a better shape for you to do the kinds of tests that you do, which is different from the kind of tests that we do. So we have to define what good is in our sense, which is not going to be the same as good is in the QA sense. I also want to relate testing qualities to code qualities. This is part of why TDD works, is because it is very difficult to test bad code, especially if you're trying to write what I'm going to call a good unit test. It just forces you to write better code, because bad design is hard to test. It just really puts your feet to the fire, right? So we'll look at the synergies there. Also about how it informs actual design, not just the quality of code, but the nature of design and why it informs the nature of design. Again, this is all circling around a selective process that helps to ensure that testing does not become a burden on the team. That's what I mean by sustainable. I also want to talk about breaking dependencies, because that turns out to be one of those things that makes it sustainable, right? And also it helps it to inform design. And then finally, I just want to tie TDD and patterns together just a little bit at the end. And I want to introduce something to you that I've been working on lately, which is a community thing. It's something I'm kind of offering up to the community, which is a central repository where we can all talk about this stuff and maybe contribute what we've learned about testing patterns and things like that. So I'll show that to you at the very end. So start by redefining what we mean by TDD. I do a lot of speaking on this topic, and I definitely do a lot of evangelism on this topic, because a lot of times frustrated developers who can't get people to listen to them will ask me to come in and help them, and I do that quite a bit, a lot of it pro bono. And one of the problems I see is that this is in a lot of people's mind, and that is that test-driven development is the same thing as writing tests first. Certainly writing tests first is something I like to do. I don't think it's a bad practice or anything. But I don't think it's accurate to think that those two things are the same thing, okay? Because writing tests first is a technique, and it's a good technique, and it can help you in a lot of ways. But TDD is a way of thinking, not anything that you do in particular. Now, I will say the two things are very strongly related, because one leads to the other very naturally. But what I'm trying to say is, just because you're writing the test first doesn't mean you're being driven by testability. And you can be driven by testability and not write the tests at all if you're thinking about the way testability affects your testing. Of course, if you're writing the test first, you have to think about it, so that's why people tend to do them together. Also, because of this pairing, people hearing TDD hear test first, and this just brings up all kinds of objections in their mind, which is, well, if we have the developers write the tests and write them before they write the code, Well, first of all, that doesn't seem to make any sense, right? Because of that definition we just looked at. How can you test something when there is no something, right? Secondly, and maybe a little bit harder to overcome, because you can kind of tell people, well, it's not what you think. But people will also have this objection, which is, well, if my developers are writing tests, then that means they're writing the test and the code now, which means that the developers who weren't able to get the code done anyway are now going to be doing twice as much work. So that's going to be a real disaster if I do that. We're having trouble getting our code written, is what I hear. How could we possibly take the time to write tests? Have you heard that one before? Or cumbersome. Because of all of this, we're going to slow down. We're going to stop dealing, or going to stop delivering a lot of business value because our developers are going to be busy writing all these little tests all the time, and we won't get our features out the door in time. And not sustainable, because now we're going to have this big suite of unit tests, which now apparently are the responsibility of the developers, and since they're spending all their time maintaining that too, well, eventually we're going to have to stop doing that, and the whole thing's going to fall apart. I'm sure you've heard that one too. So these first three things we're going to deal with by really redefining what we mean by TDD in the first place. The last one we're going to deal with by making selections about how we do it. Okay? So that's kind of where we're going. Now to do this, I wanted a problem to use, and this is always a tricky thing in teaching and in presenting. I don't like using a toy, you know, like apples and pears and things like that, because it's hard to see that it's real. But when you try to use something real as an example, well, often the example gets in the way because there's so much detail that you have to understand the problem domain, and by then you're tired, you know, so it's hard to see the point. Plus, this point I want to make about the selectivity of our tests is a really subtle kind of fine point. It's not a big deal, it's just a really important deal, and it's subtle. So if I throw a lot of code up on the screen, I think it's going to get lost. So what I've been doing recently is saying, let's take a real problem, but simplify the real problem, so we get rid of a lot of the noise in it. And I'm not sure whether that's the right way to go or not, so that's one of the reasons I'm field testing with you. Maybe this needs to have more meat to it, maybe it needs to have less, I'm not sure. It doesn't have a lot of meat, so I think it's probably more, if anything. Anyway, I did this for real. This is one of the things I did for CBS. Television stations own a lot of junk. They own cameras, and they own production vans and computers and just all kinds of stuff. And when they buy this stuff, they want to take the advantage of the expenditure to write it off their profits, right? Your profits, and you want to be able to say to the government, hey, we bought this stuff, so let us take that off our taxes to a certain degree. This is called amortization of the value, and these assets are called fixed assets. Okay, they're things you buy, right? So what we do is we give the asset an initial value, and then we give it a term, which the government tells us, how long will this thing be useful? And the reason for this is the government, if you buy a car for $30,000, the government doesn't let you write $30,000 off that year, because you're going to be using the car over some period of time, and they want you to divide it up over that time. So they will say, well, we consider cars to be valuable for 5 years, so there'll be some schedule for writing up parts of the value of the car over time. And this was a very, very large system that I designed for CBS, because they own lots and lots of stuff. And it's really complicated, it turns out, because all these different agencies that we report taxes to all have a different opinion about all of this stuff, right? So for instance, the federal government says you lose 60% of the value of a car in the first year. So their schedule is 60%, 30%, 10%, 5%, 5% over the year, right? This is called ACRS. The state government says, no, cars only lose half their value in the first year, and so they amortize it differently. If you buy if you buy real estate, the government says that's actually going to go up in value, which used to be true. So they want you to amortize less of the value in the beginning and more near the end. This is called declining balance, which sounds like it's going to go down, but it goes up. And there's about, depending on all these different governments and different states, you have 50 of them. There's probably, I don't know, maybe 50 or 60 different algorithms for figuring out how much we're writing off in the third year of a car, right? So I didn't want all those algorithms, because what's the point, right? There's one that's really easy, and I wish they used it all the time. That's straight line. Straight line says it's a $100,000 asset, you got 10 years to write it off, $10,000 a year. That's really easy, right? So in my little fantasy world here, all governments agree to straight line, right? Which is no way true. Anyway, So what we're going to do is use asset not as a persistent object, but as a processing object. So we're not going to have it record a balance or anything. We're just going to give it the ability to, once we instantiate it, say, okay, you're worth $30,000 and we're giving you a 3-year term. Tell me how much would be amortized in the second year. We can use it for processing, right? And of course, we wouldn't really need to look at the term because we're just going to do straight line, right? But I'm going to model it anyway. So imagine the algorithm is more complicated than that, okay? All right. So we're saying, all right, so how are we going to document our intentions here? We've done some analysis. We know what we want the thing to look like. Now, how do we kind of record what we think? And of course, most people would say, well, analysis produces a specification, right? A functional spec of some kind. But what kind? And there's lots of ways of doing this. So if you want to be very technical about it, you can say, we'll create, modeling diagrams, right? This is UML. You might use OMT or something else. But this kind of shows it, right? We've got this entity called asset. It stores its value and term. It will take those in its constructor, and you can ask for the write-off of any year, and you'll get an answer, right? And that's kind of a bit of documentation of our intention. It doesn't, however, tell you that it's straight line or some other stuff too, right? So we might say, well, we might instead of that, or in addition to that, do something else. We'll come up with something like a document, like a functional spec document. Or maybe we'll do this and put the UML diagrams in it. Or, some combination of things. Other people have other tools for doing functional specs. And this is nice and informing when you're doing it. It gets you to think about what you're doing and all that. And I don't think it's a bad thing. The problem is that they don't hold their value. Because what happens when 6 months have gone by and you come back to the system and you haven't touched it for a while, but you know other people have, and you want to know what it's like? Well, are these things accurate? Because if you change the code, do you have to change the spec? You're supposed to change the spec. But you don't have to change the spec. And people do all kinds of things to try and solve this problem. Like these sometimes are generated by the IDE in round trip, but we've all seen generated UML, right? And it's hugely complex and verbose and useless, right? It's not the UML we would write if we were doing it by hand. So the round trip tools help a little bit, but they produce a really difficult to use document. And of course, nobody but us can read them. And these things, well, nothing's going to keep them up to date for us, right? So they get value in the initial stages, but they lose their value over time. Another way to say this is, maybe you think people have kept it up to date, but are you sure? And there's no way to check, right? Unless you just trust people. So what you're going to have to do is go reanalyze the code and see if it matches the spec, and then, well, what's the point of having the spec in the first place, right? Okay. So one thing in TDD is we're saying, rather than creating the spec this way, what if we did it this way, right? Now, this is JUnit 4. I was on the fence as to what JUnit to use, and I used 4, and then I went out and found out how much people hate 4. So hopefully this isn't too far afield from what you're using, because I would imagine a lot of you are using 3.8. You're using 4?
Yeah, I was going to say, I haven't run across that, so at the end, if there's time, maybe you could cover that. Why people...
I can do it right now. It's just that, they stripped out the GUI runner. They made a lot of things. They took out a lot of things that people liked, I guess. I found it fine, personally, but and especially if you're using Eclipse, who cares, right? So. Anyway, so if there are people who are only using 3.8, this is not any different. It's just, we've got these little annotations instead of subclassing and things like that. Anyway, so I've said, all right, this is my test, and notice that I'm saying test asset first year straight line calculation. That's pretty verbose, right? Well, why did I write this so verbose? Because I'm writing a specification, right? I want this to be readable. Just thinking that that's what I'm doing gets me to write it differently, okay? And notice that I don't put in arbitrary values here. I randomly generate them because this is not about a particular value in term. This is about what the thing does. So if I put in a particular value in term here, I might mislead people to think that that was part of the specification, which of course is not, right? So I'm just saying, take some double number, take some integer number, and I'm going to write it off for a year. And what I'm doing is documenting the behavior, which in this case is arbitrarily simple. But whatever the behavior is, I'm saying this is what the thing should be able to do with that information, right? So that's specification. That's a documentation of my intent. And I'm also specifying all the types. That's a double, and when it's a value, it's an int, and it's a year, it's a double when we get the write-off. I'm also saying how we build this thing. This documents its constructor, just like the UML did, right? and of course how you use it, which is down here. And one other thing that people often miss, this assert equals method, or assert dot equals, or whatever framework you're using, right? They come overloaded because integers are never actual. I mean, integers are equal, but doubles and floats are actually not equal because they have a mantissa. So whenever you compare a non-integer value, you have to say to how many decimal places you want to compare it. So these assertions always come with an overloaded version that lets you put that in. Well, where did we decide 2 decimal points and not 3 or not 1 or not none or whatever it might be? Hopefully the developer didn't just say, oh, I got to put in a tolerance. Okay, I'll put in 2, right? Hopefully that wasn't the case. Hopefully we went back to the people who were writing this for and said, does the federal government want just dollars or pennies? Or do they want fractions of pennies? Maybe they do, I don't know, right? And apparently the answer was, they want pennies, but not fractions of pennies. So this also is a documentation of that specification that says, in this problem domain, we go down to cents, but we don't go any further, right? And the nice thing about this is, if I come back later in 6 months, and I compile this test, and it still compiles, and I run this test, and it still passes, and I run my code coverage tool, and all my code is covered, I'm pretty darn sure it's up to date, right? Yes?
So I understand your argument of for the purposes of I guess the documentation, the specifications saying that it should work for any integer and double combination.
Sure.
But I think there's an argument to be made that says that's risky because there may be cases where it'll pass and then other times where it won't, in which case you may get a false green.
So I kind of skipped over that just because I didn't want to get into
But
too
never
much
mind,
detail.
I didn't say anything.
But this thing here, which is just a random in Java, actually I usually make that a class. So I can constrain what I mean by any. And the other nice thing about the class is that later on when the QA folks inherit this test, which they will, they may mean something different by any. They may have a broader set of scenarios to cover. Or they may want to not randomly generate the number, but read it out of a file or as some kind of a script. Well, once it's in an object, they can just change that object, right? So it makes these tests a lot more reusable. But here I just did it randomly, just to be quick and dirty about it. You're right, I agree. Okay. So, maybe we say it this way. Test-driven development, maybe an unfortunate name. Maybe we shouldn't have said that. Maybe we're not writing tests at all when we're writing TDD tests, because that doesn't make a whole lot of sense. How can you write a test about something that doesn't exist? Maybe what we're doing is writing something that looks like a test, because we're using testing tools and testing terminology and sort of a testing framework to do it. But what we're doing is conducting an analysis to create a functional specification. That's what we're doing. That's what we're asking to be allowed to do, which nobody seemed to mind us doing before, right? And you were going to do that anyway, right? You weren't going to just sit down and start hacking, right? Yeah.
So, I understand the whole keeping up documentation issue, but in terms of delivering the product, there's the technical writers who are going to read the code.
Yeah.
So what is done about what level, behavior of the program changes? What's done about that?
How do we integrate
They
this?
still got to do the job at a certain
How do we integrate this with other artifacts? I don't think we've solved that yet, but if we think about this as the spec, that tells us we need to, right? And I think there needs to be some way to process these tests into something that is very readable for like a business analyst. And the motivation comes from the fact that I want this to be my spec, right? Yeah.
What about using a tool that kind of straddles both sides? Like
Yeah, that's what I'm talking about, yeah. I think that tool is something that maybe is in our future, and maybe that's kind of on our plate. And again, I think the motivation is that wouldn't that be great if we could just generate the epistolary documentation from the technical documentation, which we can verify anytime we want. That's what I'd like to do too. Yeah, we haven't done that yet. And of course, the nice thing about this is the automatically verifiable aspect. Yes.
But there are such tools.
There are. Okay. Well, then I'm ignorant. What are they? What are they called?
Well, there is a steep from Solutions IQ, and
Okay.
it's based on what the
Fitness and Selenium.
Oh, okay. Well, yes, I wouldn't be surprised with Fitness because once you add that layer on top of it, you're actually integrating your acceptance tests with your unit tests. So again, a little out of scope for us today, but that doesn't surprise me. They're a little ahead of us on this. Or I guess they are us. But they're a little ahead of this on this. But what I want to point out is that when you're done, however you consider this a spec, when you're finished writing it, it is a test, right? That's the persistent artifact. It's a test later, right? Because they don't go away. They stick around. And that means you can use them for refactoring and all the different things that you need a regression test suite for. But you didn't write them just for that benefit. You wrote them to be able to figure out the problem, that's your analysis, and to be able to document that analysis in a specification. So, is it double the work? I don't think so, because this is work we were going to do anyway, right? We're just doing it a different way. However, doing it this way, we get an additional value out of it that we didn't get before, because writing a functional spec or URML diagram doesn't give you a suite of unit tests when you're done. So I think the way to think about it is we're getting 2, or actually 3 values from a single effort. And this is why TDD teams actually report an increase in efficiency, not a degradation of efficiency. I think that's one reason. So that's just the first point. That's kind of overcoming some of the impediments to getting it started. But then you get it started, right? And now you're kind of responsible for it, especially if you were the champion of the thing in the beginning. So now we get to that other thing, which is how do we keep this sustainable? And it all has to do with which tests we choose to write and which tests we choose to not write. Okay. So a year goes by and the system is working, and then the feds pull the rug out from under us and they say, you know, we're noticing that you're buying an awful lot of extremely expensive things and writing them off. And we think you're giving your executives like luxury cars and stuff like that. This really happened. And so we're going to tell you that we're not going to give you any benefit for buying really expensive stuff. So we're going to say that, and of course this would be really different by type, but I'm just assuming there's one kind of asset. Any asset that has an initial value of more than $70,000, you're only going to amortize it as if it was $70,000, and the rest of it, you're not going to get any tax benefit. It's supposed to be a disincentive to this kind of shenanigans, right? So what tests do we write in order to specify that? Well, this is another test. This is a capped test. Notice here we're saying that we'll build 2 values, a capped value, which is just over the value, right? And an uncapped value, which is right at the maximum. And then the term doesn't really matter, so we'll just generate that through a class, or in this case, a random number generator. And then we say, okay, if I build an asset at the capped value and another asset, which is called uncapped asset, at the uncapped value, I can assert 2 things. That the capped asset will still amortize at $70,000, but the uncapped asset will amortize at whatever its actual value was, okay? Now, in looking at this, we say, we got to make sure that our tests are maintainable, and so we look at them with the same critical eye we look at our code, our production, well, they are our code, but our production code, right? Which is that bad things are bad things, whether they're tests or not. I see a lot of people who think that tests are an exception to this, that it doesn't matter about their quality, and it does, because you're going to have to maintain them, right? So one thing is, well, these are magic numbers, right? We don't want magic numbers in our code. We want to specify our numbers through constants, right? If the values are significant. And so we'd say, okay, those are magic numbers. Also, I got the same number in 2 places. This is the redundancy. I'm comparing 70,000 to 70,000 and putting it in 2 places in the code. Don't like redundancy or duplication in the code, right? So I can solve both of these things in the same way, which is by simply saying I will have a constant. In this case, I'm putting it on asset. Maybe I'd have a place where constants live. But in any case, this actually also documents my intention better. I'm saying whatever the cap is, when you're 1 over it, then you will have this kind of behavior. And when you're not 1 over it, then you'll have this other kind of behavior, right? And I'm showing the behavioral distinction in the system. A lot of people would do that. But I'll tell you what they might not do. They might not notice that the fact is that 70,000 is an important thing right now, because we're being told that's the cap right now, okay? And if we think of the test as its specification, then it needs to be complete, right? So this specifies the behavior, and that's a good thing. But where do we show the current cap so that that's readable in the future? That's missing usually in a lot of people's test suites. It isn't hard. All you have to do is say, okay, this test is complete by itself because this test is just about that. But I need another test that says, right now, asset cap is 70,000, right? 2 decimal places, right? Now, why would I care about that? Well, once I've got this constant in place, and if I'm being good and using it everywhere in my code as well, like where I have the test to cap, it's used there too. Then what if they change their minds? The government says, okay, some time has gone by, the economy has inflated when it used to do that. Now we're going to let you buy an $80,000 asset this year because things are more expensive. Well, if we want to do test-driven development, we want to make the change test first, right? So we don't change this to 80,000 in the test. It fails, of course, because it isn't 80,000, but none of our other tests fail. Then we go and change the code to make it 80,000, and that makes this test pass, and all of our other tests still pass, because both they and the code are dependent on the same constant. Notice we're not getting this cavalcade of failing tests when we do it this way, and that's because we have a complete specification. We also want to talk about which tests. Oh, sure, go ahead.
On 2 slides back,
Two slides.
you had this one here.
Yeah.
The fact that the results are exactly the same, don't you find that that's potential danger from a unit test perspective of a...
Which results are exactly the same? I'm sorry.
Well, asset cap divided by term and uncapped value divided by term is exactly the same value. And so if I had accidentally referenced the wrong one in the wrong order, I would have gotten this, I wouldn't have known it.
So we have a kind of test we write called a triangulation test. In other words, we write some more to go farther away and around it from different angles to make sure we're not doing something like that. And then we get this certainty that it's right. But then all these triangulation tests have a lot of duplication in them with this test. So we go back and we start removing them, right? Because we want our test suite to have a particular nature to it, which I haven't talked about yet, but uniqueness in the tests. But the problem there is that we got to make sure that we're right about that. That when tests are, we think tests are duplicating each other, and we were just using them to make sure that we're doing something right. And then we go back and remove the duplicated tests. Were they really duplicated tests? Or are they actually, did we actually now weaken our test suite? And what I used to say about code coverage tools was that they're pretty useless in TDD because we never write code except to make a failing test pass. So why would we want a code coverage tool? But actually they're useful. Because when we're doing that triangulation stuff, and then we go back to remove the tests that we think we don't need anymore because now we've identified the boundary, then we can run the code coverage and find out if they really were duplicated tests. And if after you remove duplicated tests, the code coverage is not 100% anymore, you know one of two things. Either you were wrong, some of those tests need to be put back in, or you've got some dead code that actually doesn't do anything, in which case you want to remove that too.
I had a comment about the question that was asked before. So if you are doing TDD, you are supposed to implement this test before you are actually implementing the feature in the code.
Yep.
So then this test would fail.
Yep.
If you are making the mistake that he was being afraid of making, this test would pass.
True.
So that would be a way of
That's
making
one way.
sure that because your test passed, you have a problem in your test. So I think doing TDD has this value as well, that you are validating the negative.
And I get to that. So let me get to that slide. We'll kind of bolster your point there a little bit. Okay, so it's also about which tests we don't write. Okay, and this is another thing that's not commonly talked about. Like the more tests, the better, right? Because the more tests you write, the more sure you are about your system. Well, I don't think so. And that may be true in QA. I'm not a QA expert, but it's not true in TDD because it has a very negative effect when you look at it that way. For instance, what about half the cap? That would be a test, right? Show that half into the cap, it just amortizes normally. What about the cap plus $10,000? We could show that that still is capped to $70,000, right? But there's theoretically no end to that. You could go to any length out there, right? Now, I think the QA people may have standards for how much coverage around those different scenarios is adequate, right? So we'll want to leave the door open for them to do that. But in TDD, at the end of the day, the two tests, this kind of behavior, when we're just over the cap, which is we don't calculate normally, we calculate at the cap. And this kind of behavior, which is at the cap, we calculate normally. This represents cap plus 1 on up, and this represents cap on down, because when you want to define a boundary has two sides, right? Very much like a sheet of paper, if you will, right? And that's what we're doing in this kind of testing, is we're defining boundaries, and those boundaries are specified in the test. Another way to say this is, when we're creating software, what we're doing is generating behavior in computers. That's what software is, right? It's behavior of a computer. And the behavior has distinctions in it. It behaves one way up to this point, then after that it behaves this way, right? And those distinctions are what we want our specification to show, because that's what's critical about the behavior of the object. So those are the tests we want. And the problem is that if we wrote all these other tests, well, they would all pass and fail together, right? Because they're really about the same distinction. They're just different aspects of it. And therefore, we get large amounts of tests failing, and then large amounts of tests passing, and then large amounts of tests failing again. And this is when people start to feel the weight of their test suite. Not in the beginning, but they feel it when they've been doing this for a while, and the test suite has gotten reasonably large. And what about other tests? Should we test that this algorithm that does the cap for us doesn't format the hard disk, or block port 5388, or change the system clock, or start a thread that starts eating memory, or whatever, right? I mean, again, no end to this, right? So in TDD, one thing we want to focus on is that what we're testing for is errors, not malice. And I'm not saying that malice isn't something we have to deal with, but that's a different kind of testing. It's not what we're doing here in writing our spec. And I believe I saw a hand. Yes?
I was just going to ask the question of how do I know that there's only one boundary?
You don't. I'm saying I specified that there's one boundary. There may be more than one boundary. And if there is, you have to specify those boundaries too. So either you know or you don't know. I mean, that's what the analysis is, right? Is saying what are the boundaries for behavior in this object.
So the test, then, from a documentation perspective, this is documenting that there's only one boundary.
In this case, there was. So I documented
But I don't
one
have, the
boundary.
test doesn't indicate that there's only, it doesn't test that there's only one boundary.
For this behavior, it does, because that's all I put in the test was that boundary. You get what I'm saying?
There's a difference between only one boundary and testing a boundary.
Okay. So what I'm saying is that if the specification is complete, then anything that is not specified is not guaranteed, right? And so I'm not saying that it has to work that way. This has got to match what the business rules are, right? Not the technical rules. That's what I'm saying.
But
Yeah.
doesn't the test you wrote allow you to be up to 99 cents over and still pass?
Yeah, and that's what I'm specifying too. When I say +1, I'm saying that the, what's that word? The amount by which a thing changes. I always forget this word. Pardon?
Delta?
Not delta.
Quantum.
The quantum, yeah, that the quantum is 1. If I put in 0.1, I'm saying the quantum is a penny, right? So I'm also, just like I was specifying the tolerance for comparison before, now I'm specifying the quantum, right, in the comparison as well. The thing is, you're specifying everything, so we want to be careful that what we specify is what we mean. That's what I'm saying. And you do that if you're thinking of the test as the spec. Or overall, what I'm saying is, and yes, I am keeping these examples somewhat pithy, so it's not complete. What I'm trying to get across here is that when you think of the test that way, it changes the way you write the test in lots and lots and lots of different aspects. It's really what I'm trying to get at here. So TDD is not a replacement for QA because a lot of the things about what we would call malice testing is something we're still leaving for them to do. Oh, I'm sorry, you're wearing dark clothing and sitting against a dark background.
So
Yes.
the onus is on you to make sure that you write a complete test.
Yes.
Because
And no more than that.
right.
Right.
So everything you have in the test is what you are testing.
And that the tests specify the full behavior of the system as you understand it.
So how do you verify that?
How do you verify what?
That your test is complete?
Well,
Your
what
test-
your
I mean,
test
that's,
is.
that's where it falls apart, right? If your analysis wasn't good enough, you
Hmm.
didn't write the test you need to write.
Okay. So, well, first of all, remember that the test is specifying what the system does, not what it may do, or what it could do, right? It specifies what it does. So if the specification does not indicate that it does something the customer wants it to do, then it isn't complete. But the specification specifies that it isn't complete, right? So what I'm saying is that if you write the test to specify behavior, and then you create the code that makes that behavior, then the test specifies the behavior, right? The completeness in terms of the business sense, that's not a problem I'm trying to solve. I'm trying to make sure that my specification is accurate to my code, right? So if it's wrong, at least I know it's wrong, because the specification shows that it's wrong.
But there's some kind of a process that has to be in place, in as much as that typically spec writers may not be developers.
Yeah.
But a developer or somebody with development understanding could be writing this type of a spec.
Yes. And I'm not saying that this replaces Scrum or anything that allows you to analyze your stories and things like that. We work from that, right? What I'm saying is that this documents the specification of the system, not the specification that the business has, right? That's what you need user stories for, and all the things that we talk about in Agile process. This doesn't replace that at all. This comes from that. So what I mean by sustainability, okay, just putting all this kind of stuff together, is that often TDD adoption kind of goes like this. And some of you probably been through this, right? The first is, we've got this initial adoption. If we overcome the resistance, okay, people say, all right, give it a try. See what it does. And at first it's kind of clunky, right? Because not everybody's not quite sure how to do it, and we're not sure what tests to write, and we're not familiar with the tools, and it's weird, and people just feel strange about it, right? So the teams do slow down. Everybody goes, see, I told you. You were going to slow down, right? But that's just initial adoption. And then we get competence. People start saying, okay, now I know how to work with this. It starts getting a rhythm going. It gets to be more natural to be writing tests. People aren't hesitating to do it. We start speeding up. We start talking to each other better about our tests, and therefore we're sharing information more. And then finally, we just really kick into high function. And this is when, as Kent Beck and the people up at the JUnit site said, people get test infected, right? Developers start saying, man, I don't want to work any other way. This is so great. I feel so confident. I've never felt this confident before. I know exactly what I'm doing, and I know exactly when I didn't do it right and what I did, and wow, this is wonderful, right? And you hear this sort of happy joy from these teams, right? And that goes for a while, and then something bad starts to happen. We start to struggle because we've got this reasonably developed system, and we're agilists, right? So we embrace change. And so somebody comes to us with a change, and we go, great, no problem. And we go in and we make the change, and a bunch of tests start failing. So first it's a few, and then it's 20, and then it's 30, and it just keeps happening, right? So after a while, as we keep struggling to go back to the test suite and remediate it to make it work again, after a while the whole thing becomes unmaintainable because it's taking too much time. And often what developers will do is they start disabling tests because they got to check in, right? And we'll have to fix those tests later. Or I'll hear, well, those tests aren't important because they're bogus now because they changed the requirements, right? But of course, we don't have new tests to replace the bogus ones either, right? So after a while, we aren't really covered anymore, and well, it just kind of dies, right? This is a real common path that's been going on for the last couple of years. And a lot of people are reporting this in articles and stuff out into the field, and they're saying this kind of proves that maybe this was a cool idea, but maybe it doesn't really work. Right? Smart people. People I happen to really admire, actually, like Jim Coplian. One of the people I think has contributed tremendously to our industry in terms of domain analysis, and wrote a brilliant book called Multi-Paradigm Design, and changed the way I think about domain analysis in every sense. So I really think this guy is very, very smart. And he said this in the JavaCon 2007. One of the things we see in a lot of projects is that projects go south on about their third sprint, and they crash and burn because they can't go any further, right? And he said, I think that proves that TDD is a good way to start a project, but it's not going to stay with you very long, that after a while you'll have to do something else, right? He says it's inherent, but I, with all respect to the guy, I just don't agree. Don't agree at all. And the reason I don't agree is because of somebody I know who we recently hired away from Israel. Amir Kolsky, somebody who's been doing this longer than almost anybody over there in Israel where nobody was watching, and has developed millions of lines of code this way. And we started talking to Amir about what's the difference between what you're doing and what other people are doing. And he said, well, let's look at it. Let's kind of investigate it. And then we hired him. So obviously we thought he was pretty smart. It's not because the developers are stupid or because the process is broken. It's because the developers aren't writing good tests. And that's because good TDD tests are not the same as good QA tests. And most of our testing tradition comes from the people who've been doing it the longest, right? Which is the QA people. I mean, of course we drew upon them for wisdom. And it's not their fault that we're using that stuff the wrong way, right? It's just because it's new to us. So, what is a good TDD test, I guess is the question. Let's define the good. Okay. Now, the perfect is the enemy of the good, right? So we know that we can't adhere to anything in lockstep, and I never would suggest that you should. But it's awfully good to know what the lockstep is, right? So that when you back off of it, you're doing it consciously, okay? So I'm going to state this in kind of a absolutist way, And I want you to hear that as kind of a shining goal, and the closer you can get to it, the better is what I mean, okay? Because if anything, I'm a very pragmatic guy. You don't stay in this business for 35 years without being a little pragmatic. Okay, so what is a good TDD test? A good TDD test, I'm going to say, has at minimum these three characteristics. The test will fail reliably for an expected reason. That's one thing. It will fail when you meant it to, right? That's a virtue of the test. It will never fail for any other reason. That's another virtue. That guarantees its uniqueness, right? And that it's narrowly defined. And third, that there is no other test that will fail for this same reason, which of course is very strongly related to point 2, but it's just the other side of the coin. In every test that I write and every suite that I put together, these three things are always in my mind. I want to get as close to this as I can, because if I do, then I will avoid the things that cause TDD to be unsustainable. Take them one at a time. Yeah?
So I like these rules. I know that some people interpret that to mean that each test method can only have one assertion.
I definitely don't mean that.
And that drives me nuts.
Yeah. People want to have hard and fast rules that they can be guided by. It's a very natural human thing. How many assertions should you have in your test? The right number. The number you need, right? There is no rule to it, right? If they're all about the same single behavior, behaviors can require, as was mentioned earlier, a boundary may not have, there may be just one boundary, right? You need the number of assertions that fully describes the behavior, whatever that is. But what we're doing, if we're making a spec, is analyzing behavior, right? So I don't think of it as test-driven development. I think of it as behavior-based analysis and design, which is what it really is. That becomes tests later on, right? So yes, please don't read that as meaning there should be one assert in every test. Some tests should have one assert, but others should not. So let me just take each of these together. The must-fail thing. A test must fail when the behavior it covers is the wrong behavior. That's what it should be. And that can't happen, first of all. We can accidentally write tests that actually can't fail. They have no way that they can fail, right? And that's worse than not having a test. Because for one thing, you think you have safety you don't have, so you move more boldly than you should. We think the system's working when it isn't working, because we don't have an alarm that goes off. We will when we ship it, right? And we think the spec is accurate when it isn't accurate. Because there's stuff that can change that won't affect the spec, right? All the tests pass, therefore they're accurate. Well, no, not if they're passing because they can't fail, right? So in test first, one of the nice things is that we fail the test first, right? And that means we know it can fail, which was kind of the point you were saying, that the failure tells you something too, just like the passing of it does. Now there is an unsolved problem here. And that is, although we ensure the test can fail, and of course, if the code was given to you, you have to go make it fail to make that work, and legacy code. But in either case, we've now ensured ourselves that the test can fail. But then how do we know later on that the test could still fail, that somebody didn't muck around with the test, and now it can't fail? And there isn't any automated way of solving that problem right now. Max Guernsey and I are working on a thing that we hope to add to unit testing frameworks that allows you to verify that your tests can fail when they're supposed to in an automated way as well. And we're calling it a goad as opposed to a mock. But that's not what this talk is about, and we haven't done it yet. But I do know that's missing right now. We don't have a way to verify later that our tests all possibly can fail. Did I see a hand? No.
No.
I did see a hand.
Yeah.
Okay, sorry.
So I mean, so the traits are very qualitative, but how do you actually practice it so you don't, 6 months later, all of a sudden, you don't have these qualities? I mean, how do you know you're not, it's going to be too late? You're just gonna be
Well,
buried
with
in-
this one I'm saying we don't, and that's why I'm saying we need to solve that problem. We need a way to, in an automated way, ensure that the tests could fail when they were supposed to, right? And it's similar to mocking, except we don't mock the dependencies. We actually mock the class under test and make a bad one. But right now, of course, the framework would show a failure. We want that to be a success, right? So I don't want to get into that, but we're working on it, okay? That's something that I think we need. We need these things called goads. Yes?
So one particular anti-pattern that's insidious in this way is when instead of commenting out the entire test method, or even better, at least my preference is to list that method as an exclusion,
Yeah.
so that you know that this you count how many exclusions you have. If they comment out the body of the method,
Yeah.
then you have that situation
That's
we're
failing
referring to,
passing
where it's
test,
worse than no test at all, because
Okay.
you have a test method that shows it's passed because it didn't do it.
Because in all these test frameworks, passing means no failure.
Right.
That's all it means, right? So yeah. So again, that's what's been motivating us to say, let's make sure that this actually could fail later without us actually having to go manually and do it. And right now, that's all you can do, right? To break the code and make sure something fails, right? So again, that's coming. Must not fail. If a test fails for a reason other than the reason it was intended to fail, this misleads you, right? Because you think you have a problem you don't have. The test fails, therefore the thing is broken. No, it's not. It failed for a reason other than you were writing it for, right? And also, we miss problems that we do have because we might be looking at the wrong failure up front. And we want to focus on the thing that actually is failing, not something else, and then get to the thing that's failing. And of course, if the other reason is covered by its own test, now they're failing together, right? And that's that bad road that we don't want to be on, right? Okay. Now, no other failure. I'm sorry, go ahead.
I was just going to say, some of this stuff seems to lead to the desire to have dependency graphs in your tests.
I want to have dependencies specified in my tests, but whether they would actually be dependency graphs, that's not a bad idea. I'd have to think about whether I'd want to do it or not. But I do want my dependencies to be specified in my tests, yes, because that's part of the specification, right? And that's another thing mocks can do for us.
No, I mean, if one of your tests is testing something fundamental to all the other tests, you'd like the other test not to run if that one fails.
Oh, right. So actually saying that certain tests will disable other tests.
Yes.
Yeah, that might be interesting. I don't know any framework that's doing that right now, but that might be an interesting thing.
Actually,
That's another thing for us.
Test NG has that capability.
Test, what is it?
Test NG.
Test NG?
Yeah, Test NG next generation. It's very similar to JUnit 4
Oh, cool.
annotations.
Okay. Yeah, the tools get better because we're getting these insights, right? Okay. No other failure. A test should fail alone. Two tests failing for the same reason is a bad thing and annoying, but it becomes 3, right? As the system grows, and then 13, and then 30, and then, well, we're in really bad shape, right? So, and that's why you disable them, and that's, understandable, but it's the wrong road to be on. So when we want to do that, we say, okay, we want good tests, and we mean good like that, right? That we try to add good tests, and sometimes we can't, because it just can't be, right? It gets us to rethink our design, the design of the actual thing that we're working on, right? And that's a good thing, because TDD actually is not just test-driven development. It can also be test-driven design if we let it guide our thinking about whether our design is any good or not. Now, there's all kinds of aspects to this. I can't cover them all tonight. I wanted to focus on this particular one as an example of what I mean, because this is something you could talk about for several days, right? And people do. Right? So remember this initial task we wrote. We said, okay, we're just going to say there's some double number, there's some integer, and we're going to say that the result should be any value over any term, and that we're going to build the asset this way, and we're testing against this method called getWriteOff, right? And of course, initially that isn't going to fail, but we're specifying that we don't care what these values are by using this any thing, right? So now we stub out the class so we can make it fail, because we want to make sure that the test works, and it'll compile, and then we want to make sure that it would fail if asset's not behaving, and of course it's not, because it's not remembering its term and its value, and it's not doing any write-off at all. Okay, so okay, it'll fail if it doesn't actually do it properly. And then we go back and we make it pass, right? So of course you could just return an arbitrary value, but the fact that I NE'd out those values makes it hard to do anything other than the real implementation. So I do a minimal implementation. I say, okay, I'll persist whatever you give me, and then I'll hand back the division. And remember, this would be obviously a more complicated algorithm than this, right? Okay, but that would make that test pass, okay? So then we come along later, and the government does this thing about the cap, right? So we say, okay, this is my second test, which we wrote, which says that it should have a special thing that happens when I'm over the cap, and when I'm at the cap, it should act the way it did before, and here's the special thing, and here's the thing it did before, again, showing the two sides of that boundary, right? Of course, the asset doesn't do anything about the cap, so this test will fail, right? Because this thing will actually amortize too high. It'll amortize at 7, whatever it is. It's a big number.
That's what your first test, a significant amount of the time.
Sorry?
As will your first test, a significant amount
That's
of time.
the problem, you see? Well, actually, my first test is fine right now because I haven't changed the code. This test will only fail right now. It's when...
The first test is using any,
Yes.
therefore it could be a random number, therefore it could be over the cap.
Yeah, but this test doesn't use this test doesn't use the cap.
It uses next double,
That's right.
which could be over the cap.
I know, but I'm sorry.
The code's not
Asset,
changed yet.
asset
The code
doesn't
hasn't
cap it
been
yet.
changed.
Okay.
So
Yeah.
the first test will
Will fail.
continue to work until he changes the code.
That's what I'm saying. Thank you.
Okay, fine.
The asset right now isn't doing the cap at all,
Okay.
so the first test is fine.
Okay.
But you're right in what you're saying, and that is, I got to change the asset to make this test pass, right? And as soon as I do, by putting the cap in, that's my constant, that'll make it compile, right? And then I go in and actually do this comparison, then I will get the second test to pass, but in a good portion of the time, which is a great way to say it, because it's not all the time, which was the point somebody made before, you did, I'm going to start seeing that first test kind of failing, right? Because it's randomly generated. It might be over the cap, who knows, right? It doesn't expect any capping to happen. So this will pass sometimes and fail sometimes. Now, bad thing. We don't want a unit test that passes and fails when you haven't changed the code, right? Okay. And that's because of exactly what you said. So this is information about our design. Because what it says is, and this is awfully simple, right? Very few lines, all fits on PowerPoint slides, so it's pretty darn simple. But the making of the second test pass causes the first test to fail occasionally, and that means they must somehow be coupled for them to affect each other, right? Except they're not. One test can't see the other test at all. In fact, the way the test frameworks work, it kind of ensures that one test can't see the other test, right? They're very scrupulous. They create separate instances for every test to run in most cases, and just to prevent exactly that kind of side effect. So that means they aren't really coupled, so how can one have the effect on the other? And of course the answer is because the coupling's in the production code. It's the only way they could be coupled to each other, right? Now, again, making a dogmatic point here, because you could say, go fix the first test, right? It has a bad assumption in it, a thing you didn't know about in the past. You could do that, but I'm suggesting that you might be sidestepping an opportunity to see something, because our tests talk to us. They tell us things about our code and about our design. So you may decide to do that, but before you decide to do that, I would suggest them to the test and see if maybe there's something else you want to do. Again, you might not want to, but what I always want to know is that my options are on the table in front of me so that I'm consciously deciding what I want to do, not that I didn't think of something, and that's why I'm not doing it, right? So what does this make me think of is my point. And, well, the other design might be, what if the cap is done separately? What if I pulled it out? What if it was a service that I used outside? That's a different design, right? Well, I could do that if I wanted to. And the question is, what does that actually do, right? Well, for one thing, I can cap test it by itself now. I can just give it a value, you know, right at the cap and right over the cap, and see that it always gives me back the value at the cap, right? That it always reduces it back and pushes it down to the cap, or throws an exception or whatever I think it should do. I think in this case it's pulling it down to the cap, right? And that's, of course, a design change, which the test is telling me to think about. That's why I'm saying it's driving my design. It's not creating my design, because I get to decide to do what I want to do, but the test is giving me information about design. It also means that the asset's a little bit more cohesive than it was before. Cohesion having to do with the singleness, you know, the don't repeat yourself and have one responsibility, the single responsibility principle, right? So right now the asset, well, it's losing a behavior, right? It's going off to something else, which makes the asset simpler, which has a virtue, right? So this is what I would do. I'd pull it out and say, okay, asset cap is something that I use, and I build the asset cap here, and then I use it down here, rather than doing it myself, right? However, I haven't really solved the problem yet, because when I do this, this can only fail if the cap is failing, but this can fail if asset's broken or if the cap is failing. And the reason is because I've created a dependency between the two. Now, in design patterns are very dependency rich, because one thing the Gang of Four said is a general bromide of design is that you want to favor delegation over inheritance, not to use inheritance for everything, but to use a lot of encapsulated delegation. And we see lots of value in doing that. But ironically, every time you do it, it seems like you just created a dependency which is getting in the way of your tests, right? So we have to know how to manage our dependencies in order to say, no, that's really not a problem. That's really not a quality issue because I know how to deal with it, and that's technique, okay? So it's about breaking dependencies and testing. Now this is really a limited section because this is a huge subject because there are many ways of doing this. And I'm only going to show you one because I'm already pretty much over my time. So I guess it wasn't too short. Anyway, it's about mocking, right? And again, the big subject. So I'm going to show you a very limited subset of it for those of you who haven't done this. But this is basically why we do 2 and 3 days of training on TDD, because we want to show a lot of techniques, because none of them work all the time, okay? But I'll look at a handcrafted mock, and then later on I'll show you an example of an automated mock if we have time, although I think we're running out. We'll also look about how you actually make the mock take the place of the dependency, and we're going to do that through something called Dependency Injection. Again, there are lots of ways of doing that, and we won't cover them all. Okay. So first thing I do is do a refactor to extract an interface off of asset, and it's a pretty simple one. Also, if you're using Eclipse or any kind of decent tool, it's probably got an extract interface refactoring in it, so you can do that refactoring that way. It does point out the fact that designing 2 interfaces generally does have some virtue to it, because you might have already done this just because you don't like coupling to concrete types. But in any case, we pull out that interface, and then we create a second implementation of it. And the second implementation, in this case, is very simple. It just doesn't do it. You give it a value, and it gives you back the value you gave it. It doesn't apply the cap. So it's a cap that doesn't cap, right? So we can separate out the 2 behaviors. When I'm testing this thing, I want to use a cap that doesn't cap, so that I'm not actually testing the other behavior. And when I'm testing this thing, I can test it by itself, right? So what I do here, now this is dependency injection, which is using chain constructors. There are positives and negatives to doing that. So I know, remember, there are other ways to do this very same thing. But this is a very common way of doing it, which is to say, take the old constructor, which used to do these 2 things, and chain it to this new constructor that actually allows you to pass the asset cap in. So the production code can still go on using this, but the test can use this. And that way he can hand in the mock asset cap instead of having it use the real asset cap for testing purposes. So that's dependency injection. That means that at testing time, when we insert the mock cap, we actually aren't getting any behavior here, and so we can test the old behavior by itself. And our first test won't fail anymore. It'll work just the way it did before. And remember, it's only. However, and this is a really often missed thing, in TDD, boundary tests are not sufficient. Because right now, well, we know the asset works, because it's supposed to do the divide thing. It does that, right? And we know the cap works, because it's supposed to trim you off at a level, and we have a test that says that it does, so we know that it does. And we have 100% code coverage, and we do, except only in the technical sense. Because in fact, your code coverage would say we're at 100%, right? But there is a change that we could make in the future, and, or I'm saying is there, I'm saying there is, that would break the code, but all the tests still pass. And that's not a good thing. So even though our coverage is high, the reason that this isn't working is because it isn't a complete spec. Again, it's about thinking about it like a spec, right? So what is that breaking code that still passes the test? Well, this is the class today. So let's say, for whatever reason, somebody fumble fingers the code or whatever it is, and this stuff down here is where you want to look. That, redo that. We don't apply the cap. Well, the test of asset will work because when we test it, we give it a mock cap anyway. So this is the same behavior. And the test of the asset cap will work because we're testing it by itself. In other words, we never test that the asset uses what we give it. This is not a boundary test. This is a workflow test. Right? And workflows have to be specified if they are, in fact, part of the specification. Not all workflows are. Some are just implementation details. We definitely don't want those in our tests, right? Because we want to be able to refactor implementation later and pass the same tests. But if it is a specified behavior, if it is part of the spec, then we have to put it in the test somewhere, right? And again, you still show 100% code coverage here. So, workflow, yes. And mocks can help us here too if we build it differently. And again, I'm going to show a remarkably simple one, but you can think about all the things you could do in this way. But be careful not to overdo it because you don't want to specify workflow that isn't specified. I want to say that one more time. This is one of the things I see get overused all the time, especially when you have an automated tool that does it for you, that people, the validate thing that comes in a lot of these automated mock tools. I see people using it by just de rigueur all the time. And all of a sudden you can't refactor your code because your tests are covering way too much. They're covering too much implementation detail. This is only, again, if you need it because it has to be covered specified behavior. Okay. So here's my slightly smarter mock. It's not a whole lot smarter, but I'm just storing a Boolean that says, did I ever get called? And of course, at first I didn't because I just came into being. And then down here, when you're doing the cap that doesn't cap, you just set the got called to true. Now we add this method here so that the test can go and ask it, you know, what happened to you when you were in there, right? But this method is not available to asset because asset holds it as asset cap, not as asset cap mock. This is only available when you hold the mock as the mock, which only the test does, right? So these methods are available for tests, but our production code cannot become coupled to them because they can't see them. The wonders of casting. And now we have a workflow test that says we test that the asset uses the cap the way it's supposed to. We build the mock, we put it in there, we call for the write-off, and all we assert is that it got called. And this will fail when we break the code the way we showed it before. So every boundary has two sides, and every specified workflow has a way to check it. And now we've got a complete and every constant is specified as well. Now we've got a complete spec, complete functional spec. So far, we're saying that the TDD tests are unique, that the test suite is the spec, and we just want to think about it that way, so it informs what we do, and that the D in TDD is also about driving toward design because it suggests to us alternatives in design so that we can decide what we want to do. And of course, good design is also what patterns are about, and that's why it does, in fact, synergize with patterns. Okay? All right. So how are we doing on time? I know I probably went a little bit long. How are we? I don't want to keep you guys any longer than we said we would.
We're technically here till 9, so
Yeah.
we've got lots of time.
So I'm okay?
Oh, yeah.
Oh,
Just
all
about
right.
half an hour.
I was told to talk an hour, so okay. So let's talk about the role of patterns in this, and then I've got a handout for you that I want to go over with you, because there are more than just those 3 rules. I want to talk about a few other rules, too, since we have time. I also didn't know if there's something else you guys wanted to do, so I want to dominate this. I actually gave a talk on this, so some of you may have seen this before, but I just want to include this little part of it. This is from Brief History of Time by Stephen Hawking. The story is that some cosmologist, usually Bertrand Russell, I've heard it was actually, well, somebody else, was giving a talk about, cosmology, about, the way the universe is structured, some kind of highfalutin theory about it, strings or something, right? And he goes through this whole thing and is very, scholarly about the whole thing. And then some woman in the back, who's like a Native American, raises her hand and she says, well, this is all very interesting, young man, but it's absurd. We all know that the universe rests on the back of a giant turtle. And the cosmologist kind of smugly says, well, if that's so, then what does the turtle rest on? Part of the universe, right? And she says, no, you're not going to get me caught up in that. Everybody knows it's turtles all the way down. Now, Hawking's point in the book is, that sounds absurd. So may string theory be. I mean, anything we come up with could be equally absurd, but actually it means a different thing to me, because I'm really interested in object-oriented design and how to make it good, and I use patterns as ways of kind of informing myself and learning kind of the shapes in design that give me certain advantages. So I've noticed, however, that in many designs that I actually like quite a bit, because of their flexibility and their testability, that there is that aspect to them. It kind of seems like no matter where you look, the answer is somewhere else, right? A lot of delegation-heavy design will do that. In fact, I remember when I wasn't an object guy, when I was a pattern guy, I used to tell this joke that all the procedural guys told about the object guys, right? We made fun of the object guys. With those object guys, no matter what the question is, the answer is always the same. Another level of delegation. So, well, and it looks that way sometimes. It feels that way sometimes, especially when you really are making cohesive objects, right? Lots of delegation going on. So a good example of this is the decorator pattern, which is how streaming I/O is done in Java. So I'm kind of assuming that you know the pattern to some degree. That we have some kind of operation that we're always going to do, like write bytes down to the file, right? And then we have a bunch of stuff we might do along the way that we can kind of chain in front of that object, like buffer the bytes, or convert them to Unicode, or compress them, or whatever. And the first time I saw this, I got to tell you, I thought, what the heck is that? You know, when I saw this new nested thing in order to open up a stream. But the flexibility of it is wonderful, and you get hooked on it pretty fast, right? But of course, I wasn't thinking about testing, because for most of my career, I thought of testing as somebody else's problem, not mine. So now that I really want all of my code to be tested, and I want to do it, I always think about the testability of things, and that gets me to revisit the patterns a little bit about that. Because the Gang of Four didn't say anything about testing. Zero, nada, nothing, right? And well, if patterns are good design, and if good design is testable, then they ought to say something about it, right? It just seems logical to me that there would be some confluence between the two. So you look at this at runtime, right? We see the nice, flexibility. I can build it this way, and I'll get this optional behavior before it goes down, or I could get them both, or I could do B and then A, or just B. I mean, I really have a lot of flexibility here. But then when I think about the testing, I think, well, okay, these guys are probably pretty testable because they have no dependencies. They're just at the end, right? They don't delegate to anything. But how do we test these guys? And typically also in the decorator, your return is void, right? So how do you test a void return? You call the method and nothing comes back. Pass. So obviously that's not a very good test because it can't fail, right? So this kind of gave me that feeling of what Hawking was talking about. It's just turtles all the way down, It's like everything rests on something else, and that's impeding my testing. So I got to figure out a way to not have that trouble me. And of course the answer is some kind of mock object. But the kind of mock object and where it goes seems to be, in many cases, very different per pattern. Some of them are very simple. Think of a strategy pattern. The mock is one of the strategies. Real simple, right? But when you get into like the visitor, and the bridge, and the observer, and the chain of responsibility, and the facade, you start thinking, gosh, how would I test that? And you got to kind of think it through, really into detail, right? Well, my feeling is once we've thought it through and figured out what the mocking technique is, I don't want to keep thinking it through over and over again, right? So in the pattern repository that I talked about earlier, and I'll show you in a minute, to me that goes with the pattern. How do you test it as part of the pattern? So we figured it out for a lot of the patterns, and we've recorded it as part of it, and the decorator is one of them. So in the decorator pattern in the repository, we say, okay, this is easy, right? You just write a test for the concrete component because it's not dependent on anything. But all of these decorators here inherit a dependency back to something, right? And what is the something? Well, the something becomes your mock component over here. Therefore, you can decorate something other than the real component, and that mock, therefore, can kind of report back what happened when it was decorated, and you can test the proper behavior of the decorator. Because it goes with the pattern, it's suggested by the pattern is what I'm saying, and because patterns are a turtles all the way down kind of problem, and because I like to have specific words for specific things, and because I also have a weakness for puns, I call that thing, to make these guys testable, a mock turtle. So that's my mock turtle. And every one of my patterns recorded has a mock turtle in it somewhere that says that's how you make the pattern testable. And therefore the pattern isn't poor design because it is easily testable because you can break the dependencies that actually make it strong in production. Okay? So this also is an opportunity to talk about automated mocks just briefly. And I'll show you one that I like in Java, which is Kamino Fries's Easy Mock. So here is the class. Now I'm doing a really stupid decorator because I have a decorator that converts the string to uppercase. You really need that, right? It's built into string, but it's easy to show that way. And then I have a base class for string decorator. So I would want to write a test for this decorator to show that when it decorates something, that it hands it something that has been converted to uppercase, because that's what it's supposed to do, right? Because it does, in fact, the to uppercase method. Okay, so it's a void method return, so I can't normally test it at all, right? But if if I use this mock object, I'll be able to do that. And that's the behavior I want to get to, but the behavior is buried in the object, right? So the mock's going to help me with that too. Okay, so first of all, I'm using EasyMock because I like it. And in EasyMock, to create mocking, you actually have two objects. You have the control and you have the mock. And the mock is generated by the tool. You don't write it at all. It just makes it for you at runtime. It doesn't even put anything on your disk. It just generates it, right? And the control is another thing that's generated, but the control is kind of like the little joystick that they have on the robot that they send into Chernobyl, right? So that you don't have to go into that dangerous place, right? You're standing out here, you're the test, right? But you can see what the mock sees because it has a little camera on it, right? So that's the control object. So it gives us both. The control we build by specifying the class that we're trying to mock, okay? And that's the dynamic creation of the mock. And then we can actually call getMock on the control, and it'll pull the mock out for us, and then we can insert it into our test. What we're doing here is we're building our upper decorator, which was this guy here, and we're handing him the mock guy, as if it was the concrete process that a decorator would end in, or another decorator. You can't tell. They all look the same to him. Then we actually call for the behavior. We say, we're going to say to the mock object, you should expect your process string method to be called with all uppercase A's. This is like the script that you're giving your actor, right? And then we tell the control, okay, go into real mode, so we're going to do it now. This is Houston, we're going to take off. And then we test the decorator by saying process a lowercase string, and we're already told the mock to expect an uppercase string, right? And so we say verify. Did you in fact get an uppercase string? And if you did, then that means the test decorator is working properly. So we've kind of gone around the back and caught what the thing does, right? So that's an example of using an automated mock. So it all leads to an empowering question, right? Which is, design is about decisions. I think it is. Design is thinking, right? It's how you decide what you're going to do. That's design. When you understand how TDD tests work and what they really are, and when you understand how dependencies could be mocked and therefore you're not misled by the fact that you may have a dependency or two in a good design, right? And if you let patterns suggest back to the testing maybe a better way to test, I can go either way, right? I can let the test drive me to the bridge, or I can let the bridge drive me to the test for the bridge, or both, right? Then you can ask a very powerful question when you're doing this design thing, which is, okay, how do I test this? And when I said at the beginning that you can be test-driven and never write a test, it's because you can do that. I have some people that I teach out in Philadelphia who work for an organization that I'm not going to name, but it's a big financial organization. And it's against the rules for them to write tests. It's not allowed. You may not write a test. Write a test and you're fired, right? Because they believe that developers know their code so well, it's that familiarity breeds contempt thing, and that someone else needs to test it, otherwise the test is bogus. It's very old thinking. I can't get them to stop thinking this way. It's Philadelphia. It's a very stodgy kind of town. Everybody wears a tie. You know. So I go to their testers and I say, fine, never write a test. Now let me tell you how to do it. And I teach them how to test. And at the end they go, why did you teach us this? Because you can't do it. I said, because even though you can't actually do it, wink, wink, because they do and then they throw them away. But anyway, even though you can't actually do it, when you've got something on the whiteboard that you're deciding if you want to write it or not, you could certainly say, if I was going to test it, how would I? Right? And if the answer is, I don't know, this seems impossible, it's probably not a good design. And that's a big lever on all the quality and metrical issues that drive us into good design. And I don't know anything else. That's one question you can ask like that. That really tells you all kinds of things about coupling and about the cohesion of your objects and about the focus of your objects and all of that wonderful stuff. Okay? So, what I wanted to give you, somebody wants to pass these around, maybe we'll go going two ways at once. I hope I have enough. I made 50. But just start passing these around. This is an article that's coming out in Better Software. They have this 10 things you might not know about something, and they do it in a page. I think it's on the inside cover or somewhere like that. Anyway, they asked us to do one about TDD. So me and Amir and Al and Max wrote it. And it's going to be coming out in, I don't know, a couple months or something. So I thought what I'd do is kind of go through the 10 points, just one after another, and then you can take these with you. And then if you buy this stuff, I've been saying, this is something you can share with the other people that you work with and maybe start talking about it. and how it shows up in the kind of testing that you do. Okay? So the first three things are the things we emphasized in this talk. The first one is a test should be proven to fail for a well-understood, narrowly defined reason. This is not proven that it's possible a test will never fail unless the behavior it defines is not guaranteed. When a test fails, it delivers a large part of its value since it gives us critical information for finding the source of the failure. This is why we write the test to fail and then change the production code to make it pass. This proves that the test can fail and for the reason we intend. So is that reasonably clear to people why that's a virtue? The test should never fail for any other reason than it was intended to. When a test fails, yet the behavior it was designed to cover is working properly, then the test is misleading us as to the source of the failure. Often this is due to unexpected, undesirable coupling in the production code. So if it happens, ask why. No other test should fail for the same reason that a given test will fail. Multiple test failures for a single cause create maintenance problems when new features are added to the system, when existing features are removed, or when there are changes for performance, security, or any other reason. Agility requires that we embrace change, and large numbers of test failures to a single change inhibits this, and that's an understatement, right? Especially when the test suite gets large. This can become a crippling thing. And it's not hard to not do it. It's just a little distinction that you're making, but you just have to make it all the time. And if you make it all the time, it just doesn't happen to you anymore, without any Herculean effort. This is just to cover all four. Each test should make a unique behavioral distinction in the system that no other test makes. And if you do that, well then 1, 2, and 3 are a natural outgrowth. And that, of course, requires you to think about the test as a behavioral distinction, not as a verification, right? Tests must be written within a well-understood scope. For example, if we're testing that an algorithm properly calculates tax, we do not need to write a test to ensure the code being tested does not also reset the system clock or format the disk or anything else outside of the scope. We test for errors, not malice. We did say that in this test. Point 6. This is really critical, and this I learned from Amir. And it's an easy thing to lose track of, so it's one of those things I try to keep in mind all the time. What are we testing in a test? What are we testing? Well, the answer is a test tests all those things which are in scope but not under the test's control. Think about that. If it's in scope and the test doesn't control it, you're testing it, even if you don't want to. Right? We don't want to be testing everything. We want to test one thing, right? Therefore, if we wish to test a single narrowly defined thing, then everything else in scope must be brought under the test control. If your test is dependent upon the system clock, this only happens at 6 p.m., then you're testing the system clock, even though you don't want to. You have to bring the system clock into the test control. If you're testing that this only happens when a thread completes, or when a process completes, or, well, anything, and when it's a certain state of an object, right, then you have to bring that into the test control, or you're testing that too. And that keeps you from making these narrow tests that only fail for one reason. So all these techniques about mocking, and also other things we didn't cover here, like shunting, and endo testing, and all this other stuff, all of which are well documented or trainable certainly. You have to be trained in these things, because otherwise you very rapidly lose control of dependencies, not just your own objects, but dependencies on everything, the database, the GUI, all that stuff. Right? The role of a code coverage tool in Tdd is to verify after a duplicate test is removed that a system is indeed fully covered. For example, when a test is found to duplicate the distinction of another test, one of them must be removed. If code coverage reveals an uncovered path, then either the test was not actually a duplicate or there's dead code in the system. So I actually have gone back to running code coverage a lot. I didn't used to do it. I kind of stopped after a while.
I have a question about code coverage.
Sure.
How much, like, in your experience, what's the good percentage of code coverage? Do you think 100% is achievable or sustainable?
I think 100% is required. If you are writing a test, I know that sounds pretty extreme, doesn't it? If you are writing a test, let's say that you write a test, okay, and the test fails, which it should, and then you write some code to turn the test green, and if that's the only code you ever write, keep in mind that TDD is not about getting green tests. It's about turning red tests green. That's the critical thing, okay? If you're always doing that, just enough code to turn the red tests green, well, then all the code was written for that reason. and that therefore it's going to be 100%. Now I'm making a purist statement. I am doing that on purpose because that's my goal. That's what I want. That's what's acceptable to me, and it shouldn't be a big, arduous thing to do that if I've broken my dependencies. I'm only testing the thing that's not under my test control, right? And if my specification is complete, which means the workflows have to be covered too. Had a hand over there.
I'm sorry to say, but I feel like the preaching 100. I'm someone who believes strongly in code coverage.
Yep.
Preaching 100% code coverage is a little bit like preaching teenage abstinence.
Crystal Palin today said that was unrealistic. So. Yeah, well, the reason that you feel that way is because, you know, you live in the real world, and because you've got a lot of code that doesn't have 100% code coverage, and getting it to there is going to be a Herculean effort. So I agree with you there.
Well, what I also see is that there's sort of a, you reach a point where you, diminishing returns.
But what if
say reaching 85% code coverage takes a certain amount of effort, and that last 15% is tough.
I want no effort. That's my point. I'm not talking about diminishing returns on effort. I'm talking about not putting an effort into it. I want it to be a natural outgrowth of the way I'm developing my code. I don't try for 100% code coverage at all. I just notice I have it. Because every time I write a piece of code, I'm turning a red test green. Therefore, it must be covered by the test, right? Otherwise, I wouldn't be turning it green. I mean, I know this sounds really weird, and I didn't buy it either. I mean, you know, you're being totally from the moon here. But since I've been doing a lot of projects really very strongly test-driven, when I look back at them, I find that I have extremely high code coverage, very close to 100%, if not 100%, and I never did anything to get it. It was just a natural outgrowth. Now, you know, that is if you're really doing it all the way, and I know everybody's somewhere in between. So, but I think we ought to say to ourselves that that's the acceptable thing to us. That's what we want. And by holding that in our minds and in our hearts, if you like, I think that means we're going to get closer to it all the time. I mean, at Microsoft, you know, I teach there a lot, and they have this code coverage requirement of 75%, right? That's a requirement there. So I go in and, with teams and I do test-driven development with them, and all of a sudden, I actually have a developer saying, they said the code coverage is supposed to be 75%. I said, that's right. He said, well, mine's like 99. What do I do to bring it down? I said, I think it's 75% at minimum. So yeah, I you know, the only way to convince oneself of this is to experience it. But if you work this way and you really are adhering to the principles I'm talking about, then it just happens. You just end up with very, very high coverage.
It would be interesting to have a plot of the code coverage versus the lines of testing code. And obviously it will go like if you want to have like 99 or 100%, it would just the total number of lines of test code will shoot way up.
Why?
And especially if you're talking, well, if you want to like have every getter and setter tested and like the catch blocks of things that you know they can't ever throw any exception, these kind of.
Why would you have catch blocks for something that can't ever throw?
Well, like if you're doing converting strings to different code. I mean, there's a few cases in Java where it can happen.
So
I'm just saying it certainly things.
Let me make a comment about your general point, which is that the number of lines of test goes way up. Okay, whatever reason that may be. I've seen that happen, of course. And of course, the big pathology we see is the test is significantly larger than the cat class it tests. Significantly larger. Okay? But why is that? Okay, so let's look at a class. So this is an object, and it's got some things it can do. Let's call them A and B. All right? And A can do 7 different variants of what it does, whatever that may be. You know, different orders for behavior, different things that it does. And B has 5 different things that it does. Okay? Now these are different behaviors in the system, from my point of view. So I want to write a test for these things, but I also write a test for these things. Unfortunately, because they're in the same class, I also know that every one of these things can affect these things. Right? It's possible that variables can override each other's stuff, because inside a class you don't have any encapsulation, really. Right? You make things private, but they're not hidden inside a class. So, and if I want to write, therefore, all the possible combinations of the behaviors of this object, how many tests should I write? 35 if there's no sequence dependency. The sequence dependency, we're talking about 7. Okay? Now that would be a lot bigger than this class. And if I tried to cover all of that, my lines of code are going to go through the roof, right? What if it was 2 classes? Could be, right, rather than 1. Well, I'd write 7 tests for this class, and I'd write 5 tests for this class, and I'd look at how they were able to affect each other through their encapsulated interface, not through side effects. I could identify those scenarios, maybe there's 2, right? So now I've got 14 tests to write, and none of them are bigger than the code. See, every time we see something like that, I'm making a general point, but every time we see something like that, it isn't that we're establishing some fundamental thing about testing. It's that we're establishing something about the design of our code. And this is a cohesion problem. So that's coming from objects that do too much, in most cases. Not every time, but
So
in
if
many
you
cases.
extreme, let's say you have entire applications, like one blob of code, then obviously it's going to be, you require an immense
Wouldn't
amount
it?
of code to...
Yeah,
to
and imagine
test
if it was one blob of code, and you wanted to make sure that you had unique tests about everything in it, right? Well, you would have to create all these testing points,
Yeah.
and then every one of them would have a huge setup to it in
So
order to get it
that's
to work.
that, going the other extreme where basically every class like has basically one thing and maybe has like one method.
Yeah. Well, that was the other comments you made about getters and setters, right? Do we test getters and setters?
Not really.
I don't test methods, guys. I test behavior. The method is how I get to the behavior, right? But I don't test the methods.
Okay, but
I test the behavior.
Okay, if you don't test getters and setters, that your code coverage cannot be 100%.
Didn't say I didn't. I'm talking about a way of thinking, okay? In order to test certain behaviors, I'll have to use the getter to test the behavior, okay? This is just a change in the way we think, okay? This is a spec, right? And the spec is about the behavior. Each behavior has to be tested. I call the methods, constructors, and all that stuff because I have to get to the behavior, but I'm not testing the constructors and the methods. And what that also does is it gets you to stop writing methods like test of the constructor, right? Or test of the get method, right? What you're saying is test I can retrieve the value after construction. That's what you really mean. So that gets you to write one test about a behavior that may involve several methods, and that's not a poorly cohesive test because it's a single behavior in the system. There's just several methods involved to get to it. That changes that too. So that's a short answer, but it's a short talk.
Yeah, so the getters and setters, if I look at my code, I'll have some classes that just hold some data.
Yeah.
That maybe populate in the context of like a sort of more high-level test, it's
Sure.
storing data, just dumping it down again, but sort of in context of if you're testing behavior, actually these fields are never used.
That's right, and that's why you're going to mock that thing out, because then you can test the internals of when it's used by something else, because it has no behavior of its own.
Yeah, so this field getter and setter will reduce my test coverage.
Well, again, if the getter and setter is there and you have no behavior associated with it, then what's it for?
Well,
Right.
to store the data.
Well, then it has a behavior, because something somewhere is using that to get to the behavior, right? So what I have to do...
It's pretty trivial, it's the getter and setter, so...
Is
you
it?
really want to
I
test
mean,
it.
it's not trivial if you need it. So, I mean, I would want to create a mock object and use that data object properly, and then I could assert against the mock. What did you do, and what happened when you did it? Right? And that to me is a test of the getter and setter at the end of the day, but it's a test about the behavior of using that object. You had your hand up too.
Yeah, how do you manage large percentage of test coverage if, for exception cases and exception handling, which tends to be a lot of code and
That's kind of a large...
like you said, there are checked exceptions that are declared that you have to catch because the compiler requires it, but you may have logically eliminated the possibility of it getting thrown.
It's a very worthwhile topic. It's a huge one. And it's one of the things I do a lot of training about, but I mean, I would be able to scratch the surface this evening. The way you test around exception handling is significant. It's boundaries again, right? Because there are times when an exception should be thrown. You need a test for that. A test where if the exception isn't thrown, it's a failure, which is a little upside down, right? But you got to have that test, because otherwise you don't know. Would it be thrown when it's supposed to? You got to have tests that show that the exception isn't thrown when it shouldn't be, right? And then you got to deal with exceptions you weren't even looking for, but that also could be thrown by the system. But it's too big a topic. I can't get into it now, but I'll just acknowledge that's significant too. But again, if you think about what is in the topic of this course, and that is that it's part of the spec. A lot of people would say that if an API throws an exception, what that is we're preventing that thing from happening. No, you're not. The exception is part of the API, right? If you say, if you call me with greater than 10, I'm going to throw an exception, that doesn't prevent me from calling you with greater than 10. It just means I'm going to get an exception, right? So you got to put it in the spec. It's got to be part of the testing. And it's not trivial, I agree.
principles there was to avoid having more than one test fail for the different type of error. If you have a system that has multiple layers, how do you isolate? You just use mocking so that if you have a lower layer, that it doesn't like report zillions of errors in the other place.
If you have a system with multiple layers, you have multiple problems, one of which is you have dependencies between teams, right? I'm waiting for the other team to finish what they're doing, so I can't do anything, right? That happens a lot. So the testing has the same problem you do. I can't test this thing by itself because the other thing is required. So you need to make sure that your layers are isolated from each other, but you know what? That's a pretty good idea anyway. So I tend to use facades between layers, and that's in my pattern repository, and there's actually a section about that very question, which is how you then can make sure that the tests are really not dependent upon the layers. So I'll show you the repository and you can read that section. But the short answer is that if you have something that encapsulates the layer, like a facade, you can mock that instead of the things in the layer. And that makes the testing a lot simpler. And I have a concrete example in my repository, so I'll point that to you in just a minute. Let's finish up these. So 8, to write a test is how we conduct analysis, and the resulting test suite becomes the functional specification of the system. It has advantages over the traditional spec in that the suite is written in technical language, not English. It would be a real mismatch between English and technology, right? Technology is very absolute. English is very fuzzy. Well, every human language is very fuzzy. And of course, it's verifiable as well. For the suite to fill this role, you got to write it to be read, right? And most tests are not written to be read. They're written to be executed. So now that I've been thinking about tests that way, I write them very differently. I have very verbose test methods. Why? I'm never going to have to call them. The test runner does. So I don't mind that they're really long, right? But when they're really long, they're really readable. It's kind of different from writing any other kind of method for me. The level of complexity is an indicator of the quality of the design of the system. Okay, that's this point over here. When the classes are significantly larger than the thing they test, what you're dealing with is combinatorial testing. And that's because you're glomming too many things together in the system. So I already made that point, but that's here in 29. Test suites must run fast, so they can be run frequently without excessive cost. Therefore, all dependencies to, well, there's the layer question. To the GUI, the database, the network that would make tests run slowly must be mocked for testing. I'm not saying that these external dependencies aren't going to be tested. I'm saying that that's acceptance testing and integration testing, and we don't expect to run those every 5 seconds, right? So they don't have to be so fast. So we still test those, and that's where we integrate it to Git and other tools. But when we run the unit tests, we run those beneath those tests, and we're not triggering all of those slow dependencies. We mock them out. All right. So this is what I'm going to show you the repository. Set my website, netobjectives.com. And if you go to, it's actually netobjectives.com whack pattern repository. But the other way you can get there is to just go directly to the website, which is netobjectives. And if you just go to the resources and support section of the site, you will find a link to the repository right there. But you can also just type it in yourself, pattern repository. And you'll notice that we have a little menu along the side, and they're all patterns. And then each pattern has this sort of collection of aspects to it. So like, if we look at something like, I think I mentioned the facade pattern a moment ago. So we deal with things like, well, what's it for? What does it encapsulate? How would we have done this procedurally? That's always a good thing to know. Back when we didn't have objects, how do we do it? Because sometimes you can link the procedural shape to the pattern shape in your brain, right? And if you're a good procedural programmer, you don't have to throw out what you know, right? To say, well, I would have used a couple of nested switches here. Oh, that's like the bridge pattern, right? So we do that for every one of the patterns. Some kind of non-software analog, something from the world or from life that's like this pattern. So, for instance, a facade is like the concierge in a fancy hotel, right? You want to do some spiffy thing with your significant other that involves getting tickets and booking the reservation at the restaurant and getting the carriage ride and all that stuff. Well, you just go to the concierge does it all for you, right? All those interfaces resolve down to one. I think facades are like that. Yes, sir?
Can I suggest the term metaphor?
Metaphor for what? Oh, for the analog. Yeah, it's a metaphor, sure. Absolutely. That just shows kind of a diagram of it. And here's different ways. Here's the facade using the chain of responsibility and all that kind of stuff. And then down here, we show several ways of using it. But down here is the thing I was talking about, that when you stub out the different tiers from each other when you're testing, because you don't have the interface, let's say, from the other teams. You just create some kind of a stub thinking, well, I'll just create my idealized interface that I hope they come up with, right? That thing can be mocked for testing, but then after the real tier is ready, you just convert the stub into a facade that does the translation from what you hoped they would do to what they actually did, and the mocks can still proceed to allow for the testing.
So you can actually use that for acceptance testing also,
yeah,
to make sure that it conforms.
So this repository is there, and it's free for everyone's use, and it's a WikiWeb. It's the Media Wiki software, which is what they use the Wikipedia on. So this is a place where people can also edit. You can come in and you can add what you might want to add, and give us your ideas as you give them, and suggest metaphor instead of procedural analog or non-software analog, and all that kind of stuff. Someone's pointing me over there.
Dan has his hand
No,
up.
I was going to ask, I couldn't tell from to see whether it was an open wiki and
It is.
whether you
Well,
encourage
Media
discussion
Wiki.
or not.
I absolutely do, because I don't want to be the only person writing this stuff, because I'm not the only guy with good ideas, right? So it's meant to be a community site. I did about half the patterns here, a little more than that, but people are starting to do this and come along and help us to write things. And if they have a new pattern they think, you know, they discovered that doesn't already exist, we have a patterns under consideration section. And by the way, I think mock object is a pattern. So I have a whole section on the mock object pattern, including the metaphor, which is a crash test dummy. When you're testing a car, you have a dependency, the driver. It's not a good idea to test the car with the driver, though, because you'll kill him. So we put the crash test dummy in there, and notice how a dummy works. You can position him in different ways. What if his feet's up on the dash? What if he's sitting with his arm out of the window? What if he's the passenger? What if he's sitting in the back, right? Well, we can do that with mocks. We can make them conditionable. So we can give them little scripts and say, return a 5, see what happens now, you know, that kind of stuff. But also they have these little shock sensors all over them, right? That says, my head hit the dashboard at 50 kilometers per second. Oh, you'd be dead then, right? Well, we can also make the mock objects inspectable. So after the test has run, we can say, what happened to you, right? So this is a pretty good metaphor, I think, for a mock object. But then we get into all the different ways you can do it. Direct inheritance, interface extraction, wrapping and interface extraction, automated tools, and all kinds of stuff like that. So this is a pretty good place to go and kind of investigate this stuff and play with it, but also contribute your ideas to the rest of us.
What's the URL again?
Just go to netobjectives.com, and then the resource section, and then it's on the menu.
Perhaps you can post it to the mailing list.
Happy to. Yeah, and I guess this video, if possible, will be posted there as well. So if you want to review
work
this.
on that. Yeah.
And of course, feel free to give copies of this list to people if you want to. You'll notice on the back of it, by the way, we have a thing coming up that may be interesting to you. This is just something I wanted to point out. I'm not trying to market anything here, but one of the things that people often talk about is difficulties is database. And we have a fairly smart guy in our company who has some things to say about that, Max Guernsey, who's envisioning a new kind of testing. Databases are really different from production code, and they have a different set of ethics about them in testing, which I think a lot of people struggle with. Max is one of the first people I've met who really gets it, about not just how you break dependencies off the database so you can test your code. I think we understand that pretty well. But the question is, how do you test drive a database, right? So he has invented a new kind of testing, which is similar to unit testing, but he's calling it transition testing. And it has to do with the way database changes over time. Think about it this way. Your code changes over time like this. You change the source, you make an executable. It's a little bit like the species and one individual of the species, right? When you want to change it, you just throw the executable away. And you change the species, and you make a new individual. Just like evolution works, right? Okay, in a database, the species is the structure of the database. The individual is the data. You're not going to throw that away, right? So you can't evolve the database. You can't do that, because if you do, you lose all of its value. You don't want to throw the individual away. Individuals don't evolve, right? What individuals do is metamorphose. And that has very different aspects to it. We need very different testing to make sure the metamorphosis is correct. And, well, I don't know anybody who's done this. So Max has this thing coming up called the, I think, Agile Database Bootcamp or something like that. It's all going to be done online. Unfortunately, it's not free, but I think it's going to be really cool. So I just wanted to alert you to it. And also next Monday, I think somebody mentioned it, the Agile Open is going to be downtown. And I'm speaking there, and Al's speaking there, and that's free. and you come to that. So that's on the reverse side of this list, and I just invite you to come if you think it's valuable to you. But anyway, I'm done. Unless you want more questions.